Use the quadratic formula to find all solutions of the equation in the interval from 0 to 2 pi. Enter your answers as a comma-separated list. Round each answer to 4 decimal places. So we have tan squared x plus 4 tan of x plus 2 equals 0. As you can see, we do have a quadratic equation. That's why they're asking us to use the quadratic formula. This quadratic equation is not factorable. So for example, if we use u substitution, so let u equals tan x, for example, and then we can make a substitution for all of these tan x's and tan squared x. So u squared will equal tan squared x. If we make this substitution, then tan squared x will become u squared plus 4 tan x will become 4u plus 2 equals 0. And as you can see, this quadratic equation is not factorable because there are no factors of 2 that will add to 4. We're going to use the quadratic formula. So the quadratic formula we know to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But of course, we're not using x. We're going to use u instead because we are using u substitution. So u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice that we have our a here is 1 because that's 1u squared, b equals 4, and c equals 2 because this is a quadratic equation. Ax squared plus bx plus c equals 0. Now, let's substitute a, b, and c into our formula. So we have u equals negative b, b is 4, plus or minus the square root of b squared, 4 squared, minus 4 times a times c, divided by 2 times a. So if we simplify that, we have negative 4 plus or minus the square root of 4 squared is 16, minus 4 times 1 times 2, that's minus 8, divided by 2 times 1, which is 2. So u is negative 4 plus or minus the square root of 16 minus 8 is 8, divided by 2. 8 contains a perfect square factor, which is 4. So we are going to simplify the square root of 8 as 4 times 2. And then, of course, the square root of 4 is 2. So that goes outside of the radical. Times the square root of 2 over 2. We can reduce this. So anytime we have all of these where you can reduce it or simplify those numbers, all three numbers, you need to do that. You could split it up like this, where negative 4 is being divided by 2 plus or minus 2 square root of 2 is divided by 2. Then you'll know that negative 4 over 2 is negative 2 plus or minus these 2's cancel out and you have the square root of 2. So right now we have that u equals negative 2 plus or minus the square root of 2. Now what is u? Well, earlier u is tan x. So really this is tan x. Tan x equals, so this u equals negative 2 plus or minus square root of 2 becomes tan x equals negative 2 plus or minus square root of 2. So therefore tan x equals negative 2 plus square root of 2 and also negative 2 minus the square root of 2. And if you wanted to, you could put this in your calculator and you can see that it's, for example, negative 2 plus the square root of 2 is approximately negative 0.5857, for example. And if you wanted to, just to see what that equals, but we're not done because we haven't solved for x yet. We're still at tan x equals. So let's keep this. How can we get just x from tan x equals -2 plus square root of 2? And how can we get just x from tan x equals -2 minus square root of 2? Well, we can do the inverse tangent. So we can do inverse, right? Inverse of both of these. So inverse of tan x and inverse of -2 plus square root of 2, for example. That would just give us our x equals. And if you put this in radian mode, then you'll see that if you put the inverse tangent of -2 plus the square root of 2, you're going to get approximately, so let me put my squiggly equal signs, -0.5299. Since this is not in 0 to 2 pi, then we need to think about the period of tangent. So we know that the period of tangent is pi. So for example, a general solution for this one would have been inverse tangent of -2 plus the square root of 2 plus n pi, because we know that, or pi n, however you want to write it, that tangent's period is pi. Now we know that this number does not fall between 0 and 2 pi. So what we're going to do is just add pi, right? If we add pi, and we know pi to be approximately 3.14, but I want you in the calculator to add the actual pi. All right, if you add pi, you'll get 2.6117, where we know that that is between in the interval 0 to 2 pi, because 2 pi is approximately 6.28. So all we need to know, we need to make sure these numbers fall within the interval from 0 to approximately 6.28. All right, and let's add pi again. If we add pi again, we would get, it will still fall in there. You can approximate it in your head. It will be 5.7533. So this is another answer. Now, if you add pi again, you'll realize you will be outside of 6.28, since pi is approximately 3.14, right? So you add 5 to that, that's going to fall outside of this interval right here. So we definitely have two answers. Now let's go to the other side. We do the inverse tangent of tan x and -2 minus square root of 2. Then you will see that and again, the general solution would be this plus n pi. However, they want us to use the quadratic formula to find all the solutions within the interval 0 to 2 pi. So if you put this in your calculator, the inverse tangent of -2 minus the square root of 2, then you will get approximately -1.285872 ... But that's of course not within the interval 0 to 2 pi. So again, we're going to add pi to that. You get approximately 1.8557. So that is a solution. And of course, you can approximate in your head. If you add another pi, it will also be within that interval 0 to 2 pi. So the final answer would be 4.9973. So here are the four different answers: 2.6117, 5.17533, 1.8557, and 4.9973. I hope this helps.